Okay, so now we'll do the same question using the formula. Using the formula, Sn plus 1 is equal to Sn plus a. So what does the question says? The question says that the displacement and the increase of the velocity from t to t plus 1. From t to t plus 1, the displacement is 125. And the change in an increase in the velocity is 50 meter per second. So if we have v as the initial velocity, v plus delta v as the final velocity, then we know that change in or increase in velocity here would be plus 50. Why? Because it is given that increase in the velocity. Increase means delta v should be equal to positive. If it was decrease, it should be delta v is equal to minus 50. Okay. Now, for this motion alone, AB alone, for the movement of object along AB alone, we can say that v is equal to u plus at, where v, the final velocity, is velocity at p, u, the initial velocity, is velocity at a, which I have assumed it to be v plus delta v and v respectively. So we can say that vb is equal to v plus delta v and va is equal to v. So this becomes v plus delta v is equal to v plus a into t is tb minus t1, t at b is t plus 1, t at a is t. So this becomes t plus 1 minus t. And therefore v minus v, so v minus v, oh sorry, my bad. So we have v minus v is 0, t minus t is 0. So that gives us the answer as a is equal to delta v, and delta v is 50. Therefore a is equal to 50 meter per second square. Yes, this calculation remains the same, right? We've been doing this for the past two questions. Now, what differs here is this formula, Sn plus 1 is equal to Sn plus a. Now you might be asking the question, Sn plus 1 is already given to us, in which case what should we do with this equation? Well, we can make use of this. How? We have been asked to find out t plus 2, which means, or rather n plus 2, which means I can switch this n plus 1 to n plus 2. How? Replace n by n plus 1. So Sn plus 1 at n plus 1 becomes Sn plus 1 plus 1, which becomes 1n plus 2. Similarly, Sn becomes Sn plus 1. Or in other words, Sn plus 2 is equal to Sn plus 1 plus a. What is Sn plus 1? Given the question that t to t plus 1 is 125 meter, therefore this becomes 125 plus a. What is a? We found out the value of a to be 50. So 125 plus 50, which gives us 175. Okay, therefore the distance traveled by this particle in this would be 175 meter. Okay, now if you want to see how did we arrive at this particular equation, it's actually a very straightforward derivation. So we have Sn is equal to u plus a by 2 into 2n minus 1. How did we arrive at this? We already discussed this a couple of times, so let us not spend our time in going through the same thing again. Now what I've done here is I've replaced n with n plus 1. So what do I get here? Sn plus 1 is equal to u plus a by 2 into, replace n with n plus 1. So what we get is 2 into n plus 1 minus 1. Right? So this is n plus 1 is equal to u plus a by 2 into n plus 1. Let me just check this. So we have 2n plus 2 minus 1, which is equal to 2n plus 1. Right? This expansion over here. And therefore, Sn plus 1 is equal to u plus a by 2 into 2n plus 1. Now, what is Sn? Sn is equal to u plus a by 2 into 2n minus 1. Right? Now, we will subtract these two equations. So the LHS becomes Sn plus 1 minus Sn, right? Sn plus 1 minus Sn. The RHS becomes u minus u0. A by 2 remains constant, so we can take a by 2 constant. And then what we have is 2n plus 1 minus 2n minus 1, right? So this gives us further 2n minus 2n is 0. 1 minus minus 1 becomes 1. 1 minus minus 1 becomes 1 plus 1, which is equal to 2. And 2 by 2 is 1, which gives us the equation Sn plus 1 minus Sn is equal to a. So that's what we have made use here. Okay, so yes, you can do this question this way as well. Okay, so that's it with this question. Let's move on to the next one.